Section 12.2 here might appear to go in a very different direction from section 12.1, but I promise you they will come back together again in section 12.3. So we're going to talk about exponential functions here in this section, and then you'll get to see how that's related to composition and inverse functions from 12.1 later on. Exponential functions are technically a new type of function that we haven't studied before, but luckily they're not particularly difficult. What we're basically doing is taking the idea of power functions, things like x squared or x cubed, and sort of reversing where the variable is. Instead of having the base vary with a fixed exponent, we're going to have a fixed base and allow the exponent to vary. So to know what these graphs look like, what we're going to do is we're going to graph several of them all in the same graph grid, so that you can see sort of overlapping them, how they're related and what minor differences there are from one to the other. And in order to draw the graphs, we're going to do the most basic and direct thing possible. We're just going to make a table of values. We're going to plug numbers in for x, we're going to do the arithmetic, we're going to figure out what y is, and then we're going to plot the points. So let's start with an easy one. Let's try plugging in 1. Because 2 to the 1, that's really easy. 2 to the 1 is just 2. And if we try plugging in 2 to the second, that's 4. And if you plug in 3, you get 8. Notice it's always 2 for the base, and it's the exponent that's changing. So you're doing 2 to the first, 2 squared, 2 cubed. The next one would be 2 to the fourth, and you'd get 16. Going in the other direction, plugging in smaller numbers, you have to use somewhat fancier arithmetic. You have to remember things like what happens when you use an exponent of 0. 2 to the 0 gives you 1. Anything to the 0 gives you 1. And even trickier here, you have to remember what negative exponents do. Negative exponents do reciprocal. So 2 to the negative 1, that's going to be a half. And 2 to the negative 2, that's going to be a half squared. In other words, a fourth. And then plot those points and see what you get. So let's do the easy ones that don't have fractions in them. So 0, 1 would be right there. 1, 2 would be there. 2, 4 would be there. 3, 8 is up there, and then 4, 16, and etc. would be higher and higher and higher up to the right. So to the right, the graph is curving up, and it looks kind of like a parabola, but it's a little steeper than a parabola. It's kind of curving up, though. The other direction, though, is kind of interesting. When you have negative 1 for x, your y came out to be a half. And negative 2 for x gave you a quarter. And if you think about it, each step to the left you go, you're multiplying by a half again. So it'll be an 8th, a 16th, a 32nd. So to the left there, this graph is getting smaller and smaller and smaller. Each dot is half the size of the previous one, or half the height of the previous one. So it's kind of leveling off along the x-axis here. It never quite equals 0. It doesn't matter how negative your exponent is. The fraction you get will still be a positive fraction. But it's definitely leveling off and becoming microscopically close to that x-axis. That type of behavior, where the graph sort of follows a straight line off to the side, the word for that is asymptote. This graph has an asymptote on the x-axis. And that's an important word because these graphs are all going to have asymptotes somewhere, and that's a very important part of the graph to recognize and understand. So our first one, f of x equals 2 to the x, it curves up like this. Asymptote to the left, curves up through 0, 1, starts to go up really rapidly, and then goes off the top of the paper. If we look at this next one, where the base is 3, I'll go a little quicker here, because we've already kind of got the idea. Again, I'll plug numbers in, and I'll do the arithmetic, and I'll plot the numbers that we get, plot the points. 3 to the 0 is also 1. Anything to the 0 is 1. 3 to the 1 is 3. 3 to the 2, 3 squared, that's 9. 3 to the third is 27. So you'll notice these numbers are getting big faster than those numbers did there. We had 2, then 4, then 8. Here we have 3, then 9, then 27. So this graph is going up faster. If I plot the points, 0, 1 is there, right at the same height as the other one. 1, 3, that's a little higher than the blue point. 2, 9, that's a lot higher than that blue point there. And then 327 is way the heck up off the top of the graph. So this purple graph, it's steeper than the blue graph, but it's not that different. I mean, visually, they both kind of just go up to the right. The purple goes up faster, the blue goes up slower, but they both go up to the right. When you plug in your negatives, you get 1/3, this one gives you 1/9, and if you compare them to the fractions we had before, 1/3 compared to a half, 1/3 is smaller. So the purple dot is below the blue dot there. And 1/9, that's definitely smaller than a quarter. So that's below the blue dot there. But visually, on the actual picture, yeah, it's below, but there's so little room there that it almost looks the same. When you're actually drawing this with pencil and paper, you have to draw really carefully to try to make that visually different at all. So to the left, the difference is very minor. It's a tiny, tiny difference. You'd have to get out a magnifying glass to see the difference between those things there. So it still has an asymptote to the left. It also goes through 0, 1, and then it goes up faster than the original one did. So you should start kind of guessing your way forward. If you've got 2 and then 3 made it steeper, you should already guess what 10 is going to do. I'll make a table of values, but it'll be a pretty quick and easy table of values. I'm going to plug in 0 and 1, and you'll see even 2 is already kind of ridiculous. If I plug in 0, 10 to the 0 is 1. Anything to the 0 is 1. So that's that same point right there at 0, 1. If I plug in 1, I get 10, which means over here it's already at a height of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's already way the heck up there. And if I try plugging in 2, it's 100. There's no way I'm going to graph that. That is quite nearly vertical. It's going up really rapidly there. And in the other direction, if I plug in -1, it's already down at 1/10. So this thing drops down to that asymptote and levels off super fast, way sooner than the other ones did. So, yeah, the red graph is different from the blue graph and the purple graph, but not really in any major way. Yeah, it's a lot steeper than the blue or the purple graphs were, but it's still kind of the same overall structure. The only way you get a really different structure is when your base is less than 1, like this one here. I'm going to make a little bit more extensive table of values for this one just to make this point. If I plug in 0, I still get 1, just like all these other ones did. Anything to the 0 is 1. But notice that when I plug in 1, 1/2 to the 1 is a half. So this graph is dropping. If I plug in 2, I get a quarter. And the 3 would give me an 1/8. 4 would give me a 1/16, and so on. And those numbers should sound familiar. I mean, we just did something like that with the blue graph. The only difference is here, the asymptote is happening to the right instead of to the left. But these numbers we had here, that's the same as what's happening down here. And if you see that relationship, you can probably guess what's going to happen when I plug in negative numbers. A fraction with a negative exponent, the negative exponent does reciprocal, which makes it 2 or 4 or 8 or whatever. So yes, the green graph, it's just a mirror image of the blue graph. Those same points except on the left, and these points down here except on the right. So if you have a base less than 1, if you got a fraction for a base like that, your graph will come down from above and level off on the asymptote. But it's still kind of the same sort of curve. So you'll notice that there's this unifying principle. All exponential curves have an asymptote that they, either on the left or on the right, usually on the left, level off at. And then on the other side from the asymptote, they curve up very rapidly. Sometimes more rapidly, sometimes slightly less rapidly, but they curve up dramatically compared to the asymptote. That's the basic shape of the graph. the sort of thing that you're going to have to do is be able to take that one more step along and do slightly fancier problems. We're going to expect you to do things like this. And at first, what I suggest you do is make a table of values. Do things in a very rudimentary, step-by-step, careful fashion. And once you've done enough with them the table of values way, you might start to see shortcuts. And if you're pretty confident of your shortcuts, please feel free to go ahead and use them all the time. So, with this one here, let's start with 0. And if you plug in 0, you're doing 3 to the 0 minus 2 plus 1. 3 to the 0 minus 2 is 3 to the negative 2. And 3 to the negative 2 is 1/9. So that's a fraction. 1/9 plus 1, that's 1 and 1/9. If I plug in 1, I get 3 to the 1 minus 2 plus 1. That's 3 to the negative 1 plus 1. That's 1/3 plus 1. So again, that's a mixed number. That's 1 and 1/3. And the first one that comes out not to be a fraction, that comes out kind of nice, is when we plug in 2. Because 2 minus 2, that's where you finally don't have a negative exponent anymore. You got an exponent of 0. 3 to the 0 is 1. So that's kind of the first nice point on this graph. If I plug in 3, that also comes out nice. 3 minus 2 is 1, so your exponent is a nice positive number, just like you prefer. 3 to the 1 is 3. 3 plus 1 is 4. If I go the other direction, that thing we had happening with the fractions earlier on, it just gets worse. Here, if I plug in negative 1, I'm doing 3 to the negative 3 plus 1. 3 to the negative 3 is 1 over 27. And if I add that to 1, I get the mixed number 1 and 1/27. Same idea if I plug in negative 2. Negative 2 minus 2, we've got an exponent of negative 4. 3 to the negative 4 is 1 over 81. And if you add 1 to that, you get 1 and an 81st. Notice that as this x gets smaller and smaller and smaller, negative 3, negative 4, negative 5, negative 6, what's going to happen is this green fraction is going to get smaller and smaller and smaller, which means what you're going to have here will always be 1 and something small. So when you go to plot these dots and you want to graph what this thing looks like, it's not going to level off at 0. The graph isn't going to have its asymptote along 0. Here, the graph is going to level off at 1. As you use more and more negative numbers for x, you're going to get, like in this case, we've got 1 and 1/81st there, and we had 1 and 1/27th, 1 and a 9th, 1 and a 3rd, and then finally 2 there. So the asymptote isn't at 0 this time. The asymptote is a horizontal line, so its equation is y equals something, and it's y equals 1, because that's where it's leveling off. When you take a paper test, when you take the test for this section and you're writing this on paper with pencil, you have got to draw that asymptote. Because if you don't have that dotted line there and you've just got some sort of an arrow pointing to the left, it's not clear to the person reading it where you meant that line to go. Did you mean for it to drop all the way to 0? Well, that would be wrong. Where did you want that to level off? So you have to draw that dotted line and label that. That's not optional. In the other direction, based on what we expect this thing to do, it's going to curve up. We had 2, and then we've got 3, 4. If we go one more than that, if we plug in 4, just to see what's happening here, we get 3 squared plus 1, that's 9 plus 1. So that comes out 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this thing is curving up over here. And if you look at this curve for this one, and I kind of gave you a big hint with these green numbers here, you should recognize that that's really the same curve that we had back here. This curve here, 1/9, 1/3, 1, 3, 9, 27, etc., that's the same as these numbers here. So your graph you get is the same shape, but it's oriented differently. The asymptote is shifted up, and the whole graph is shifted up, and the whole thing is kind of shifted over to the right a little bit. So once you've practiced enough of these sort of the straightforward way with the table of values, you'll eventually notice that there are shortcuts that will allow you to graph these things faster. And if you put in enough practice, you can be really quick at graphing these problems. You could theoretically, with enough practice, have done a problem like this in a minute or two at most. It could be really, really quick if you put in enough time and practice.